So the radical section is in the same section as the exponents because radicals are exponents. The square root of x is the same as writing x to the half. Cube root is x to the third, and so on. Fourth root would be x to the fourth. Now what if we had something like this? So the laws of exponents work. So we've got the square root of x to the third. So the square root is a half power, and inside the half power we've got an x cubed. So when the exponents are touching like that, they multiply, so that would be 3 over 2. Because that 3 is like a 3 over 1. And you would multiply fractions. When you multiply fractions, you multiply the top and you multiply the bottom. So an example would be this. If we had 4 cubed to the 1/2, that would be 4 to the 3 over 2. That really doesn't have much meaning to us, and it might work out nice and it might not work out nice. But what I want to show you here is to figure out if it works nice or not is you can do 4 cubed first. 4 times 4 is 16. 16 times 4, you might have to think about that a bit, is 64, but maybe you don't know that right off, or you can't figure that out, or the number is bigger than 4. Okay? But can we do the square root? Yeah. I showed you in the last section that exponents, when they're multiplied, you can actually multiply them in either order. Right? They don't have to be in that order. When you multiply two numbers, you can do them 5 times 2 or 2 times 5 is the same thing. What's the square root of 4? 2, and then we cube it, which would be 8. And you could, like I said, do 64, and then the square root of 64 is 8. But the numbers may not always be something that works out. So if, for example, you saw the square root of 25 to the 6th, you can choose either to do the square root first or do the 6 first. And 25 to the power 6, you'd have to write that down. But the square root of 25 and then to the power 6 works as well. 5 to the 6. And then in calculus, we would leave that like that because, I mean, I'd expect you maybe to do up to a cube. The numbers were small, 4. 5 to the 6 you could do by writing it out. 5 times 5 is 25. 25 times 5, 125 times 5, and so on. Okay, 6 times. Okay, so let's write an instruction as simplify. Square root of x to the x squared is what? Just x. Now, if we want to be technically correct, we would write absolute value of x, but I'm not expecting you to do that, okay, because we don't really need the fact that the number answer is always going to be positive when you take a square root. We don't really need that for what we're doing. But, and what this is talking about is something like this, is actually the answer is 3, not -3. So they don't actually just cancel out like you're thinking. You can only do this one way. You would have to square it first as 9, and then the square root of 9 is 3. You can't do this one the other way. You can't do the square root of -3 and then square it because the square root of -3 is undefined. Okay? So the answer is always positive. That's what that absolute value means, is your answer is positive. Okay. Now, that all being said, don't get too confused. In calculus, it's enough to say that this is just x. And then if you're plugging numbers in, you might have to worry about the domain, which they teach you about in calculus a little more. I'll keep talking about it a little bit, but you see that later. And why does it cancel? Well, this is 2 times 1/2, which is 2 over 2, which is 1. All right. Okay, so what about this one? The cube root of x to the 6. 6 times 1/3, just 2. Now, they don't always have to work out nice. You can have a fraction as an exponent. I'm going to show you what we're looking for here. But this would be x to the 5th times 1/2, which is x to the 5/2. So that doesn't work nice. But can we simplify it so that some of it doesn't have that square root? So x to the 5 is x to the 4 times x to the 1. Add the exponents so you get a 5. With square roots, you can break up the parts as long as they're multiplied. So x squared is this first part, and this is still x to the 1/2. You can't do anything with that. All right, now, you've maybe not seen it look like that before, but I want you to think back to something you would have done before. So, say we have the square root of 8. You want to write that as a mixed radical. You want to reduce it. So what you say, and this is exactly what I've just done here, but I've done it with variables. Right here, we would say this is equal to 4 times 2. 8 is 4 times 2. And you can do the square root of 4, but you can't do the square root of 2. So you would leave this, square root of 4 is 2, and you would leave the rest of it under the root. Do you remember doing that? So that's what I just did here. I said x to the 5th is x to the 4, because I can take the square root of that, and then there's one x left over that will have to stay under the square root, or with a 1/2 power. So that's the same idea as what you've seen before, but with x's. So looking at that, say we had the square root of 300. We could write that as square root of 100 times 3. We know the square root of 100. And root 3 would have to stay, so the answer is 10 root 3, as sort of as a mixed radical. That same rule sort of works for cube roots as well. I put 16 here, but you can't do this cube root of 16. You can do the square root of 16, but this is not a square root. That's a cube root. So what does a cube root mean? Perfect. The cube root is 3 numbers that are all the same, that multiply to give 16. Is that possible? This is where you do the factoring. So the 16, the factors of 16, 4 and 4. Is that 3 identical numbers that multiply to give 16? No, there's 4, but not 3. What's 2 times 2 times 2? 8. So 16 is 8 times 2. We can do the cube root of 8 because that's 2 times 2 times 2. And there would be 1 2 left over. Cube root of 56. So we know the cube root of 8. 8 times what is 56? 7? Okay, so it's not enough to be able to do these with numbers. You have to be able to do these with variables. What about this one? Cube root of x to the negative 3. Negative 3 times 1/3 is negative 3 over negative 3, which is negative 1. And that's 1 over x. Look at this one. Now, I'm actually hoping you'll all do the right thing here, that you won't make a mistake. What's the answer to this, just as a single number? 5. (16 plus 9)? Okay. And what's the answer to this one? Four plus 3, 7? Are they the same? No. And hopefully a lot of you know that and didn't do the wrong thing. But when it comes to calculus and you end up with something like this, you all of a sudden forget that rule, that you can't put the square root over two things if there's a plus or minus sign in them. And what do you think people write for this answer? X plus 2, which is totally wrong. You cannot, this is not equal to the square root of x squared plus the square root of 4. When can you break up and put the square root over terms? Right, when they're multiplied. If this was x squared times 4, then we could say the square root of x squared times the square root of 4, which would be x times 2, or 2x. Always just multiplication, yeah. Just multiplication. What's that? Well, division is multiplication, yeah. So yes, division. Let me just write that on a new page. I'll just write an example so you can see. So, this is the square root of x to the 4 over the square root of 16. But this is not a new rule because we already did the rules of exponents, and the square root is an exponent, and the rules of exponents, we had this is a to the n over b to the n. All right, you can apply the exponent to both, so you can apply the square root to both because the square root is an exponent. Now what about this? This actually can be simplified. Not by putting the square root over both pieces. We can pull the 4 out by writing it as 4 on 2, so we can factor the 4 out. X plus, if we take the whole 4 out, 4 over 4 is 1, so x plus 1. And now we can split this up because these two are multiplied. X plus 1 we can't do anything to because you can't split it up. And we see that a lot in calculus, and it often will look with actually trig in it, is the way it looks, and it would be something like this. I often put a little tail on the end just to show you what's under the square root. If your square roots are too long or too short, then you will lose marks for that. They have to go over the whole thing that you want the square root over. But here we can factor out a 25, so we'd be left with 1 minus sine squared. And now that these are multiplied, we can do the square root of 25 and the square root of 1 minus sine squared. 25 is 5, and we just leave that. A couple more little examples. So just like we did in the last section on exponents, I said inside the bracket you should simplify first if you can. So does anything cancel or simplify inside this bracket before we apply the square root? Well, the 49 and 25 don't. So they would have to stay. But the x's, we can cancel out an x. There's 1 on top and 3 on bottom, and we can cancel out a y. So if we were to rewrite this, the 49 is still there. And what else on top? So one of the x's cancels, so we'd be left with x squared on the bottom, because there was 3 on bottom and only 1 would cancel. On the 5 y's on top, 1 on the bottom, so we just still have 4 y's on top. So it would look like that. And now what might we do? Just like with exponents, we're going to, if that was a squared, we would put the squared with everything. Now we put the square root with everything. So this would be the square root of 49, square root of y to the 4, square root of 25, and square root of x squared. And we actually know all of these. If there was one you didn't know, it would just stay as a root. But the rest of them would work out. And we can do this by putting square roots over because they're all multiplied in there. If there was a plus sign, you wouldn't do it. So this is 7, y to the squared, y to the 2, 5, x squared and the square root, they would cancel. That would be your answer. So just have one more comment. What about negatives under a square root? We're doing pre-calculus. Calculus is always in real numbers, so we would just say undefined. But can you do the cube root of a negative number? Yes, that's negative 2, since negative 2 times negative 2 times negative 2 is negative 8. You can't multiply two negative numbers and get a negative for a square root if there's 2 of them, but cube roots or any odd root, we can actually get a negative. Okay, so we'll do a few more of these examples next time, but that's enough to do the homework.